Alright, this video is over Module 5. We're going to be looking at quadratic equations. So the form that we're going to be looking at, we have f of x equals ax squared plus bx plus c, where a does not equal 0. And it says that the quadratic is a second degree equation and the graph will be a parabola. So whenever you're given the quadratic equation in standard form, then you can find the vertex and the intercepts. The vertex is going to be this right here in the highlighted part. We've got negative b over 2a comma y. And there are a couple of examples that you can look at. Finding the vertex, and then the x and y intercepts. And then if there's just some examples for if you cannot factor, use the quadratic formula. So look at some of these examples on the notes. And then look at the different graphs that go with it. So that is 5.1. 5.2, we are looking at quadratic equations in vertex form. And so f of x equals a times x minus h squared plus k. And then it tells you that the vertex is going to be h comma k. And then the vertical line at the vertex is a line of symmetry. And then there's some graphing techniques. So we've got our translations, our shifts, and then like if our graph is stretching or shrinking, vertical, horizontal, what to look out for in your equations. It says if A is positive, the graph will open upward, and if A is negative, the graph will open down. And then there's some more examples down here. And as usual, I'm going to be working through the homework problems just to give you some extra examples. You do have all of these examples, then everything is explained on your notes, but I'm going to let you look at those, and then I'm going to do the homework problems separately. Projectile motion problems. So there is going to be a problem that talks about this. It has a formula for the projectile motion, and it tells us what each of these is. We've got our initial height, initial velocity, and then there is an example for that. And okay, so I'm looking at the homework for 5.1. I've got this little blank sheet over here, and we're going to go through some of these questions. Let's look at number 1 first. These are multiple answers. So in this one we've got A, B, C, and D. So we're going to be given a quadratic function, and then we're going to be finding the vertex, our axis, domain, and range. So just remember, I'm going to write this out at the top. We've got f of x equals ax squared plus bx plus c. And then from this, we're going to find our vertex. This is going to equal negative b over 2a comma y, or hk. So depending on the form that we are given. So number 1, Number 1 says to graph the quadratic function f of x equals negative x squared plus 6x minus 12. And then we're going to find the vertex, axis, domain, and the range. So our vertex equals, we're going to use this negative b over 2a comma y. So for our x, we're going to have negative b over 2a equals, we need to figure out where b is and where a is in our formula, in our equation. So b is going to be this second piece where we have 6x. So I've got negative 6 over, and then 2 times a. In this case, a is going to be negative 1. Okay, so I've got negative 6 over, and then 2 times negative 1 is negative 2. So these are going to cancel out and become positive, and then 6 divided by 2 equals 3. So for x, x is going to equal 3. I can plug this into our formula. So f of 3 equals negative 3 squared plus 6 times 3 minus 12. So 3 squared is 9. 3 times 3 equals 9. And so I've got negative 9 plus 6 times 3 is 18. And then minus 12. So if 18 minus 9 is a positive 9. And then 9 minus 12 gives us a negative 3 for y. So our vertex equals 3, negative 3. This is our answer for part A. All right, B is going to be our axis. That is going to equal x, which is going to be 3. C is going to be our domain. And let's go ahead and graph this. All right, so I'm gonna go to y equals, and I've got negative, oops, I don't want second. I want alpha x squared plus 6x minus 12. I'm going to graph. And so we can see, let me zoom out a little bit. And we can see that this is going on, and our domain is going to be negative infinity to infinity. So the domain equals negative infinity to infinity for our range. So it is coming from negative infinity, coming all the way up where y equals negative 3. That's where our vertex is. So let me zoom back in. Okay. So I can see 1, 2, 3, 1, 2, 3. This is where our vertex is. So our range is going to be negative infinity to negative 3. We put our bracket because this endpoint is included. Alright, so let's put everything in. Our vertex is going to be negative 3, oh, I'm sorry, positive 3, -3. All right. So now we do need to graph. So it is a parabola, and my vertex is 3, -3. So if you look up in the yellow highlighted, it has their vertex. And I need it coming down. So I do need to find another point in order to graph. So let's plug in. Let's look at where x equals 4. F of 4 is going to be negative, and I've got 4 squared plus 6 times 4 minus 12. So 4 squared is 16, and then we have our negative 16 plus 6 times 4 is 24, and then minus 12. So 24 minus 12 gives us a positive 12, and then minus the 16, we've got negative 4. So my other point here is going to be 4, -4. Save. All right. The x-axis, x equals 3. The axis is x equals 3. Domain, I've got -infinity to infinity. I need to be in the box. I'm going to copy this. And then our range is -infinity, comma, -3, and then we've got our bracket. All right. So there is a test question like that, and there's a couple test questions that go over this. This is going to be the same exact thing. I'm not going to look at number 2. Let me look at number 3. I'm not going to look at number 3 or 4. Let me look at number 5. Okay, so number 5. We have f of x equals -1/2 x squared minus 7x minus 43/2. So we've got some fractions, and so that's what's going to make this a little bit harder to work with. So the first thing that we're going to do is find our vertex. Remember, the vertex is going to equal -b over 2a comma y. So let me rewrite that. -b over 2a comma y. All right, so here we've, for -b to a, so in this case b is going to equal -7. So I'm just going to leave our negative symbol, and we've got -7 over, and then I've got 2 times a. A is -1/2. So we've got lots of negatives going on. Let me rewrite this. -7. So I'm going to cancel these 2 negatives out, and we are left with the 1 negative. And also I'm going to cancel our 2's out, because 2 times 1/2 is just equal to 1. So we end up with 7 over 1, which is just 7, and that we have to move our negative over. So in this case, x equals -7, and I'm now going to plug this in for x. So f of -7 equals, so I've got -1/2 times -7 squared minus 7 times -7 minus 43 over 2. So negative 7 squared is going to be negative 7 times negative 7. So negative 7 times negative 7 is going to be a positive 49. And then we still have this negative 1/2. And then negative 7 times negative 7 is a positive 49. And then we still have this 43 over 2. So if we multiply everything by 2, we can get rid of our fractions. We have to do it to both sides. So I have to do it to whatever is in our left side, which is y. So yes, the 2's cancel out, and we are left with negative 49, and then you have to multiply 2 by 49, which is positive 98, and then we have negative 43, and then this equals 2y. So 98 minus 49 is a positive 49, minus 43 is a positive 6. So 6 equals 2y. So if we divide both sides by 2, I get y equals 6 divided by 2, which is 3. So our vertex is negative 7, 3. And let me look at the graph. So one thing that I want to show you on the graph is how to trace. So whenever you graph your formula or your equation, you can hit this button that says trace. And you can use your arrows on your keyboard to move from the left and the right, and it will go across the parabola, your line, whatever it is. And you can see where your whole numbers are going to be. So I'm going to use this right here where it says x equals negative 5 and y equals 1. We're going to use that to graph in Pearson, because you do need another point to graph in Pearson. So you're going to use your vertex whenever you set your parabola up, and then you're going to put it on the point x equals negative 5, 1. So I did actually go through the homework already, and I didn't realize that I was not recording. But this is what your graph would look like. And you have your x-axis, which is just your x from your vertex, so x equals negative 7. The domain deals with our x. X is going on and on and on. If we were to zoom out from our graph, we could see that x continues from negative infinity to positive infinity, and then your range comes from negative infinity and it stops at positive 3. So we do use the brackets. So those are the questions from 5.1. Let's look at 5.2. So 5.2, we are looking at some of these graphs, and we are going to match them with what is going on. So I'm going to give you just a summary of the graphing techniques. This is for 5.2. I need to put 5.1 up here. So for our graphing techniques, we have f of x equals, and I'm going to change up some of these colors. I'm going to put a right here. Just remember that it goes with purple. So it opens up if a is greater than 0. So opens up if a is greater than 0. It opens down It opens down if a is less than 0. It is vertically stretched if the absolute value of A is greater than 1, and it vertically shrinks, vertical shrink, if the absolute value of A is in between 0 and 1. So if it's a fraction. So that is what you need to know for A. For H, I'm going to put this one down here. It is a horizontal shift. And it goes H units left if H is greater than 0. And then it goes H units right if A is less than 0. H is less than 0, sorry. And then the last piece is K. So K is our vertical shift. And it goes K units up if K is greater than 0. And then it goes K units down if K is less than 0. All right. So let's look at some of these questions. Let's look at number 1. So we're going to match. We can just drag these down to our problems. There's 4 different problems, 7, 8, 9, 10. And we just need to match the explanation. So let's look at number 7. It says that y equals x plus 7 squared plus 8. So don't forget that your vertex for this equation is going to be h. Okay. So x equals h and y equals k. So let's look at number 1 on 5.2. So we've got 7 is y equals x plus 7 squared plus 8. So I know that our vertex is going to be negative 7 and a positive 8. So let's look at our options. I know that these two at the end are both the same vertex, negative 7, 8. I just need to see if this graph is opening up or opening down. So it opens up if A is greater than 0, and it opens down if A is less than 0. So in this case, we don't really have an A right here. Since there's not a number, we know that it's just 1. So A is greater than 0. So that means that it is opening up. So I'm going to use this. The vertex is negative 7, 8, and it is opening up. Okay, so x equals negative 7, y equals 8, vertex equals negative 7, 8. Okay, so that means that this other one, number 9, where we have 7 and 8, is going to be this other piece, but it is opening down because we've got -1. All right. All right, so the other two, we know that the vertex has to be -8, 7. We just need to see if it's opening up or down. So we're going to use that information. It opens up if A is greater than 0 and opens down if A is negative. So number 8, our A is negative, so it's going to be opening down. And that means that this is going to be our last equation. Great. So there are a couple questions like that. Let me look at... And then there are questions like this. So they actually have the graph, and then you have to match the graph with each of the functions. So let's look at what we have. Number 4. So I'm just going to put A instead of 15. I'm not sure why it's 15. So f of x equals x minus 4 squared minus 3. So our vertex here is going to be +4, because remember our format is where x is minus h and this one is minus. And then our y is -3. And then, so it looks like 4, -3 is going to be over here. And it is opening up because we have a positive A. Okay, in this case, A is just 1. So our vertex would be different on part B because 3 is positive. So it +4 and +3. Bam, bam. So it would be this second one right here. Okay, the next two are going to be -4 because we have a positive, and remember it has to be minus h. And then, so it looks like 17 is going to be a positive A, so it's opening up, and then the other one is negative, so it's opening down. So I'm going to get this one first. It is opening up, and our vertex is -4, -3. Okay. And then our last one would be this last piece. It is opening down because we have a -A. And then we have -4, +3 as our vertex, which is right there. All right. Number 5. I am going to do one like this. So let me get like a purple color or pink. Number 5, I have, so similar to what we were doing in 5.1, we just have a different form of our equation that we're looking at. So x plus 1 squared. All right, so in this case, we don't have a k. So this would actually be +0 because there's nothing there. And we don't have an A, which would just be a +1. So A equals 1. H equals -1 because remember it's x minus h. And then K equals 0. So on this one, our vertex would be -1, 0. -1, 0. Great. And then we are going to graph. So let me put this in my calculator. And let me clear this. So I've got x plus 1 squared. graph. All right, so I'm going to click trace. So we'll use x equals 0 and y equals 1 to graph. So I'm going to click on our graph. We know we have our parabola, and I know that our vertex is at -1, 0. So I'm going to do x equals -1, y equals 0. And then our next point going up, x equals 0 and y equals 1, so 0, 1. We'll click to put the point, save it, and then we can check it. Our axis, x equals -1. Our domain is -infinity to infinity. And then our range, so we are actually starting from 0 and we are going on into infinity for our y. All right, so there is a question like that, and then this is very similar. They just actually give us a k, so there is a question like that on the test. And then there's gonna be one like this as well with the fractions. So practice these on your homework, and let me look at for 5.3. We're going to be doing number 1. And it is going to be the rocket launch. So there is a test question like this particular question. It says that a toy rocket is launched from the top of a building that is 62 feet tall at an initial velocity of 243 feet per second. So basically, we are on top of a building and we are launching a rocket. Okay, we'll just do this. We are launching a rocket. The rocket is going up and then it is coming down and it is hitting the ground. So there are 4 different pieces to this question. Part A says we want to give the function that describes the height of the rocket. So it tells us that our building is 62 feet tall. And our initial velocity is 243 feet per second. 243 feet per second. And then our initial height that we are starting at is 62 feet. So part A is the function. So we are going to use the equation given to us in 5.3 notes. S of t equals -16 t squared plus our initial velocity times t plus the initial height. So S of t equals -16 t squared plus the initial velocity times t plus our initial height. So we're going to plug in our values that we got. We were given these values in the question. S of t equals -16. Oh, I'm sorry. Oh yes, that's -16 t squared plus 243 t plus 62. I'm never gonna get this done. So this will be our answer for part A. They already give you S of t. We just need to type in the rest of our equation. So -16 t squared, we're going to use this box down here, plus 243 t plus 62. Okay, this is part A. Part B says that the rocket reaches its maximum height of blank feet after approximately how many seconds? So we are looking at our vertex because we want to see where the rocket reaches that maximum height. So we are going to be looking at this point right here. So our vertex, remember previously we found our vertex using that x equals negative b over 2 times a. And in this case, we're not working with x, we are working with t. So we're going to set t equal to negative b over 2a. So in this case, b is going to be 243, so I'm going to do negative 243 divided by 2 times negative 16, and we can put this into our calculator. So negative 243 divided by 2 times negative 16. And I get 7.59. And it tells us that we want to round to the nearest hundredth. So this equals 7.59. Hundredth is 2 decimal places. So our time is going to be 7.59 seconds. And now we can plug this in and solve for y. So S of 7.59 equals negative 16 times 7.59 squared plus 243 times 7.59 plus 62. And again, I'm going to put this into our calculator. Negative 16 times 7.59 squared plus 243 times 7.59 plus 62 gives us 984.64. So this is going to be our height. So when we are putting these answers in, we have a maximum height of 984.64 after approximately 7.59 seconds. All right. Part C, the rocket will be more than 313 feet above ground level for all values of t in the interval. So we want to see our time for when the rocket is 313 feet above ground level. So let me go back to the blue. Part C, rocket greater than 313 feet. So we are going to set our formula, our equation. So we are going to set our equation to be greater than 313 feet. So negative 16 t squared plus 243 times t plus 62 is going to be greater than 313. And we're going to solve for t. So we need to move 313 over, and we want to have this greater than 0. So negative 16 t squared plus 243 times t, and then I've got 62 minus 313 gives us negative 251. Or minus 251 is greater than 0. I can now use our quadratic formula to solve for t. Remember, our quadratic formula is negative b, negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So I'm going to plug in everything from our formula. So I'm going to plug everything in from our equation. I've got negative b, so b is 243 plus or minus the square root of 243 squared minus 4 times a, which is negative 16, times c, which is negative 251. And then all of this divided by 2 times negative 16. I would definitely recommend putting all of this into your calculator. So I'm just going to create parentheses for our top, and I've got negative 243. I'm just going to start with the plus, the square root, so second, and then that is the square root button, 243 squared minus 4 times negative 16 times negative 251. Okay, so this is all in our square root. That looks good. I'm going to close our parentheses because this is our numerator, divided by 2. I'm going to also put this in parentheses. 2 times negative 16. And for this one, I get 1.11. So instead of retyping all of this, I'm just going to use my up arrow and highlight this formula and hit enter. And the only thing that I have to change is this to our minus sign. So we've got negative 243 minus all of this, and I can hit enter, and I get 14.07. So I get 1.11 and 14.07. When you enter this into Pearson, you're going to put it into parentheses because it wants it as an interval, and so it would just be 1 point. So it would just be 1.11 comma 14.07. Alright, let me close my parentheses over here. Let me... Alright, and then part D says that the rocket will hit ground after blank seconds. So we want to see when our rocket will hit the ground. So we need to set our formula equal to 0. So I've got negative 16t squared. Oh, I'm sorry. Plus 243 times t plus 62 equals 0. And I'm going to use our quadratic formula again. And I've got negative 243 plus or minus the square root of 243 squared minus 4 times negative 16 times 62. And then this all over 2 times negative 16. So I'm going to do it the easy way again. I'm just going to go up and highlight. And all I'm changing is the 251 to a 62. And I do need to do both plus and minus, but we can see here. Let me go ahead and do this. So we have a negative 0.25 and then we have 15.438. So we know that it can't be a negative time, so it has to be 15 point. So I've got negative 0.25 and 15.438. So it's going to be this one because it can't be negative. So it will hit the ground after 15.44 since they want it rounded to 2 decimal places. All right, that is it for this one.